You're welcome to Educational World Selaxi. Thank you for tuning in.
This is National Open University of Nigeria, Physics 101. And in this question, we're looking at a typical thermodynamics question. Alright, meanwhile, if you find this channel informative and educative, I would like you to hit the subscribe button, the like button, and the notification icon for more videos when I upload one. Now the question goes as follows. The gas in the cylinder shown in the figure is a pressure of 5,000 pascal and the piston has an area of 0.1 meter square. As heat is slowly added to the gas, the piston is pushed outwards a distance of 5 centimeters. If 50 joules of heat is added during the expansion, calculate the change in the internal energy of the system, assuming that the pressure remains constant during the process. So this is the question. All right. So if you are a student of the National Open University and you're offering Physics 101, please don't forget to like, share, and subscribe and send to your friends. All right. So let's go ahead and tackle this question. The change in the internal energy of a gas is given by delta U is equal to Q minus W. Now, this formula is used when the system is doing work to the surroundings. So as you can see, the piston is pushed outwards. All right. So that is the formula we use when the system is doing work to the surroundings. So there's an increase in volume, or when work is done to the system by compression. Okay. Now the change in the internal energy will be that U is equal to Q plus W. Now more work is done to the system, so there will be an increase in internal energy. So where delta U is change in the internal energy, Q is the applied heat, while W is work done by the system or work done to the system. So this is it. This is the formula for the internal energy of a system. Remember, if the system is doing work to the surrounding, part of the internal energy is used to do work to the surroundings, so the value of the internal energy will be reduced. That is why we use the first one that has to do with minus. But when work is done on the system from the surrounding, now the internal energy is increased. That the work done is adding to its internal energy. So we will use the second formula that has to do with plus. So when work is done by the system to the surrounding, the internal energy will be reduced because the work will be negative. We come with negative. Okay, because the work is stemming out from the internal energy of the gas. Whereas once work is done on the system, okay, then the internal energy will be increased. That is that. So now let's go ahead to analyze the work done by the system. So analyzing work done, from physics, we know the formula for work done, right? So we already know that work done is equal to force times the distance. Work done is force times distance. Now let us go ahead and break down this work done. But before we do that, we know that pressure is equal to force over area. Therefore, we can say that force is equal to pressure times area. Force is equal to pressure times area. So we are going to substitute this force into the initial work formula. Okay. So when we do that, when we substitute that force is equal to pressure times area into the work formula, we will have that work done is equal to pressure times area times distance. Now, there is an interesting thing to know that area times distance is equal to volume. Now, area in this case is the base area of this cylinder, or the base area of the piston, as indicated. Whereas the distance covered here now is the height, that delta S. The distance here is delta S. So if you look at it now, that is a volume. We are looking at a volume change there now. So, and area, base area times height or distance is volume. So we can now represent work done as simply to be pressure times volume. pressure times volume. So work done is now pressure times volume, PV. Your work done is PV. Okay? All right. Now, since this system is doing work to the surroundings, the change in the internal energy of the system will be given by delta U is equal to Q minus W. Like I said, that is the formula we use. Then substituting the values where necessary. So work done there will be changed to PV, and volume is what? Area times distance. So that's why we have delta U is equal to Q minus P times A times change in X, which is distance covered. So from the question, we are given that pressure is 5,000 Pascal, area is 0.1 meter square, the quantity of heat supplied is 50 joules, and the distance is 0.05 meters when we do the conversion. So we are going to substitute the values where necessary into the equation. There we are going to have that the change in the internal energy of the system will be heat, which is 50 minus 5,000 times 0.1 times 0.05, and simplifying we will have that the change in the internal energy of the system is 25 joules. As simple as that. Don't forget to like, share, and subscribe to this channel if you find this channel informative and educative. All right. Have a wonderful day, and thank you for tuning in to my channel today. Bye.